who's back? Back again. This guy right here. For module 5.1 and 2, today we're going to learn how to write linear equations from graphs, tables, and situations. Then we're going to model and compare linear relationships, red letter, yellow letter, between two quantities. Alright, so the good thing is, a lot of this stuff right here is stuff that transcends. It slides into this module. Stuff that you've already seen in module 4. It's the same stuff that we start off with here in module 5. I want you to be able to write a linear equation from this graph. The good thing is, we already know a linear equation template. We know this one right here. Y equals mx plus b. In order to write an equation of y equals mx plus b form, you need two things. What are they? What do you need?
Slope and y-intercept.
You need the slope and you need the y-intercept. Specifically, you need to find the m and you need to find the b for the line graph below. The good thing is, one of those is very easy to find. Which one of those is very easy to find, Jason? Which one of those is very easy to find? The m or the b? The b. What is the b? The b is the y-intercept. So looking at this, what's the y-intercept? 8. So the y-intercept is 8. Specifically, it's the coordinate pair. What's the coordinate pair? 0, 8. And the reason it's so helpful to do this first is because to find the slope, I need how many coordinate pairs?
2.
2. By finding the y-intercept, I already have one of them. So, 0, 8. I want to use that one. I like anything with 0. And then I have to look somewhere along this line, and I have to find another good coordinate pair. Anybody have a good coordinate pair looking at their paper? What do you got, Maria? 6, 6. Yep, see right there? Two intersecting lines. That's a good point. So, 6, that's actually right over here. Nope, you go back. I'm going to write you over here. 6, 6. All right, and we're trying to find the slope. By now, we should all know how to use this one. y2 minus y1 over x2 minus x1. Roman numeral mode. Looking at this, I have two coordinate pairs. Just in case we forgot this over a little time off there. Which one of these four numbers here is my y2?
Y2 is 6.
Could be, but remember, we have two y values here. What are your two y values? 8 and 6. And although either one of these could be y2, it doesn't really matter which one you make y2. It's easier if you make the larger one y2. The reason for that is so that for the numerator, you will always have what type of number?
Smaller number.
Somebody said it. You'll always have what type of number?
Positive.
You'll always have a positive. I always make this the y2 when I subtract the y1. Won't I always end up with a positive numerator? Yes. So there's a reason behind the madness. y2, then what's this?
X2.
And what's this?
X1.
Okay, so once we organize that, by now most of us know how to do that, we can go in and we can substitute that into our formula. Julio Dominguez. Julio, tell me, what am I writing? I'm taking those, going in the formula. What am I writing?
8 minus 6 and 6 minus 0.
8 minus 6, and then
6 minus 0.
And then
0 minus 6.
0 minus 6. You've got to be careful with that. Remember, y2 minus y1, x2 minus x1. We like to subtract smaller numbers from bigger numbers because it gives us all positive numbers. Fortunately, that's not always the case. Here we're going to end up with 2 over negative 6. Can you simplify that?
Negative 6.
No, that would be 6, negative 6 over 2. The larger number here is the denominator. I can simplify this to a smaller fraction, but this will never be an integer. So, I can simplify this. You know how? Okay, so, we got to find something called the greatest common factor of 2 and 6. Now, the good thing is 2 only has 2 factors. What are the factors of 2? 1 and 2. So, the factors of 6 are 1, 2, 3, 6. So, what's the greatest common factor?
3.
Tell me the factors of 2 again.
2. 1, 2.
1 and 2. Tell me the factors of 6.
1, 2, 3, and 6.
Okay, so the greatest common factor is the largest number they have in common. So what's the largest number they have in common? 2. So the greatest common factor is 2, which means I can divide both of these by 2 to reduce this fraction. This is going to become 1 over negative 3, which we can just write as negative 1/3. Make sense? Okay, so now that we found the slope, we have the y-intercept. We're going to go and we're going to put those here. Slope, negative 1/3. Y-intercept we found in the beginning was 8, and I can write an equation for this. Adrian, what's my equation?
Y equals 8x plus.
Hold on. Remember, it's y equals mx plus b. M. What's your m here?
1/3.
Negative 1/3. So try the equation one more time.
Y equals negative 1/3 x plus 8.
Perfect. Y equals negative 1/3 x plus, there you go. Forgot the x. Y equals negative 1/3 x plus 8. Y-intercept, the slope, you put it together, you write an equation. The good thing is we've done most of this before because the way that I show you guys module 4, we work a little ahead. So when we get to module 5, we can slow it down a little bit. And we allow anyone else who still has any questions on any of this to catch up with the rest of the class. Question on the first one. We're going to try one more. No? Okay. All right. Now for this one, we actually want to go in and we want to evaluate the equation. We should know how to write an equation at this point. But the next step is to then evaluate it. Well, what do you mean by evaluate? I mean, we've been writing all these equations, right? They have to be used for something. So real world situation. The graph below right here represents the money that you, hopefully, one point in the future, save each month. How much money will you have saved 63 months after you open the account? To solve this problem, you first have to write an equation. So the equation for this graph would be, anybody? I'll tell you. Y equals 1.5x plus 3. The reason I'm using a decimal here is because we're dealing with what? Money, dollars and cents, makes it easier. I'm going to give you the equation for this one because I expect that you guys all know how to write equations at this point. That's not the goal of this slide. The goal of this slide is to identify how much money we will have saved 63 months later. I want you... Hold on. We have an equation. What's your question? You have a question? So, what's your question? Where did I get the 3 from? Remember, the 3 is the what? What's the 3? The slope of the y-intercept. What is it, the slope of the y-intercept? What is it?
Oh, the y-intercept.
The y-intercept. So, let's look here at the graph. What number falls in between 2 and 4? 3. So my y-intercept was 3. So that's my equation. The goal of this is for us to figure out how much money we'll have saved 63 months after we start this. So if we look at the graph, y represents money and x represents what? Months. And we want to find out how much money we'll have saved 63 months later. All that means is I'm going to take 63 and I'm going to substitute it in for what variable? X. So to do that, I substitute. And it becomes y equals 1.5. The x is replaced with 63. 63 months. X represents months. I substitute 63 in for x. The x is gone, totally gone, from this equation. We're trying to find out the y, how much money we will have saved. So, I substitute in and then I multiply. I do 1.5 times what? 63. That will give me 94.5 plus 3. The biggest mistake, most common mistake here is people forget to do the addition. They'll multiply and they'll think they're done. They forget about this little thing right here. But if you look at the graph, did we start at 0? No, we started at 3. The good thing is you started with money in the bank. That's a great thing. I have money in the bank already. So, you substitute, you multiply, and then you have to add them together, and you should end up with $97.5 Why? Because this is in thousands of dollars. So after 63 months, you've saved $97.5 Wouldn't that be awesome? I wish I had that bank account instead of mine, which would probably have a lot of red in it. What's up?
Doesn't that mean that that would not be proportional?
Yeah, it's not proportional. It's not a proportional relationship because obviously when we look here, when you, let's say this is your bank account, when you opened it with how much money?
$3,000.
$3,000. If you had opened the account with nothing in it, right, it would be proportional. However, this will never be proportional because when you opened it, you started with $3,000 and then you're putting 1.5 or $1,500 in each month. 63 months later, you have $97.5 thousand or $97,500, whichever way you want to look at it. Okay, what's up?
So the y-intercept is how much money you started off with.
How much money you started? It's the initial value. It's the beginning. Remember, M is how you move. B is where you begin.
Okay.
So we began this bank account with $3,000. We then evaluated this equation at 63. Boom, 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 and we solved that problem. The reason I didn't show you guys how to write the equation here is because by now I expect all of you guys know how to write the equation. This is the only little thing we add in for this chapter, is figuring out how to evaluate these equations. Do you think we're always going to be evaluating for x? No, sometimes we will evaluate for y. Not yet, but there are some times. Any questions on this at all? All right. So 4, 3, 2, 1 on this. Quick review here, because you've seen this slide, parts of it before. When given a table, the y-intercept, which is also known as the initial value, is the coordinate pair where the value of x is equal to 0. This was in the last module. I bring it up here because now we're going to be writing equations from tables. However, as we know, it's not very often that we're given the y-intercept in a table. This would be great. It would make my life so easy, kind of like with a graph. I'm given the y-intercept, I just have to go find the slope. However, if we look down at this table here, am I given the y-intercept? Yes or no?
No.
No. So I have to go find the y-intercept. But to find the y-intercept, first I need to find the slope. So we can use any two coordinate pairs here. These are all coordinate pairs, x and y. So, Catherine, what two coordinate pairs do you want to use?
5 and 15.
5, comma 15 and
20, 45.
and 20, comma 45. All right, so Catherine, what is your, what's your y2?
15.
15. Now, okay, it could be. However, we have two y values, right? 15 and 45. It doesn't matter which one you make the y2, but
45.
we want 45 to be the y2 because that way we get a positive numerator. It makes it simpler for us. So this is my y2, which Catherine, this has to be your what?
X2.
Perfect. That makes this y1, that makes this x1. Okay. Sergio,
Yeah.
tell me what is going into my formula. How would I write it?
45 minus 15,
Okay.
and then 20 minus 5.
45 minus 15, and then 20 minus 5. That gives me 30 over 15. So my m equals what?
2.
2.
80.
My m equals 2. Now that I know the m, I can go in and I can find the b. Here.
Yeah.
I want to find the b. I know the m. I have a whole lot of y-x coordinates. All I need to do is solve for b. So here's what you have to do. Pick a coordinate pair. What do you want to use?
5 and 15.
5 and 15. We're going to substitute in the y, the x, and the m here to go and find the b. So what goes here?
The y?
What's your y that you picked?
Oh, 15.
15. So 15 is equal to, my slope is 2. What's my x? You picked it already.
Okay, 5.
5 plus b. So 15 is equal to 10 plus b. I want to get b alone. So, Julio, what do I do to get b alone? What do I have to do here to get b alone? I don't multiply. I have 15 is equal to 10 plus b. I need to get the b alone. So I have to get rid of the positive 10. How do I get rid of a positive 10? I subtract. So I subtract 10 from both sides. And that gives me 5 is equal to b. So my y-intercept is 5.
Can I say the equation?
Simon will say the equation. Simon, what's my equation? It's y equals
Y equals 2, and then plus 5.
what are you missing in there?
X.
Yeah, y equals, say it again. Y equals?
Y equals 2, x plus 5.
Perfect. Y equals 2x plus 5. That's how you write an equation from a table, just in case some of that slipped out of your mind. I show you that because on the next slide, You're going to be given the equation. Once again, you have to evaluate it. But I want to make sure, if you don't know how to do this, you'll never be able to evaluate. Any questions on writing equations from tables? Let's review. Okay. So here, you work for supercellular. The table below tells us how much you will make in total depending on how many cell phones you sell. So how much would be made if 47 cases were sold? I made this one a little harder. I even took away your x and your y. Remember, from the very beginning, you have to identify the input and the output. So we have sales per day and daily pay. Ian, what's my input? What's my output?
Your input and your output. So the input would be the day, the sales per day,
Mm-hmm.
and your output would be the daily pay.
And the output would be your pay. Good. So this is my x, that is my y. In case you ever run into a table where they don't give you x and y, you have to remember how to find input and output. So we go, and I want you to follow along with me, because by now I expect you guys to know how to write the equations. I'm going to pick two coordinate pairs, 26, 230. I like the small ones, smaller the better. Makes me draw it easier. And then I'll let you guys pick. What's the other one you want to use? Any of them, doesn't matter. 28, 236, okay. 236. And then we'll put these into our slope formula. I'll give you guys a second to catch up, and I want someone to tell me, what am I writing in my slope formula? What would I write?
Y2.
Oh yeah, but what numbers would I put in there?
Oh, you are right. 236 minus 230
Over.
over 28 minus 26.
Which, after all that happiness, simplified down to 6 over 2, which is what? 3. So my m is equal to 3. And then I go and I find my b. This we're not going to have you guys do with me, because I want to make sure we understand how to do it. Some people are like, wait, how do I do that again? Kayla! Where's Kayla? Put Kayla way over there. She's like, what? Way back here. Kayla, to do this, you must first pick a coordinate pair. What do you want to use? You need a y and an x.
26 and 230.
26, 230, doesn't matter if we use the same one again. So 26, that is a 6, by the way, that's a 2. Right there. Okay, so, you tell me. I'm substituting those in to find b. What goes here?
230.
230 equals
30.
3 times
26
26
plus b.
plus 8. I perform the multiplication. 230 is equal to 78 plus b. And then, what do I do, Jason, to get the b alone? What do I got to do?
Subtract.
I subtract what?
78.
Yep, I subtract 78 from both sides. So I subtract 78 here, I subtract 78 here, and I end up with, hold on, Jason, what do I get? Anybody want to help him out? What do you get? Not 52, but 152. You gotta be careful. 152 is equal to b. So I know the m is 3. I know the b is 152. I know the equation that represents this table is what, Annabelle? What's the equation that represents this table?
Y equals 3x plus 152.
Good, which is great. Now that we know the equation, we can evaluate it to find out how much money we'd make if we sold how many cases? It says at the top, 47 cases. Kayla, did I ever give you a ticket?
Yeah.
I did? Okay. So, Hannah, what was my equation again?
Y equals 3x plus 152.
So that's my equation. Let me ask you a question. Cases, sales. What am I substituting in for, x or y? X. So I substitute for x. It even says it right there. I'm just making sure I have someone paying attention. All right, so I substitute in for x. Y equals 3 times 47 plus 152. Notice the x, I took it, I threw it away. Or I threw it up in the air. It's gone. It's replaced with 47. I then multiply, and I get y equals 141 plus 152. The very last step is for me to add together, and then I get the answer to my question. which is what, Liana? If I sell 47 cases, how much dinero do I make?
300.
Shh. Liana, how much do I make? $293 when you sell 47 cases. Once again, this is not hard. The only thing that's new here, totally new, is you evaluating the equations. We've practiced writing them before. This is not new. None of this is new. Only this, the substitution. Any questions on that before you travel on your own? No. All right. Bar 3. Ooh. Like those wrestlers. All right. So, we did graphs. We did tables. Now we're going to do situations. We're writing a linear equation from a real world situation. Once again, we must identify two things. We must identify the slope, m, and the y-intercept, aka the initial value. We must have those two things. We always need those two things when writing a linear equation. The good thing is, it's just two things we need. That's it. Some problems you'll have to go in and do the slope formula, but not all of them. Some of them are pretty straightforward. I want you to think about this. You go to the bowling alley. You pay $5 to rent a pair of shoes, and it's $8 per game. One of those numbers is the slope. One of those numbers is the y-intercept. Hold on. Some people may already have it, but let me explain how you determine which is which. The y-intercept, aka the initial value, is the upfront fee. The thing you pay only once. The starting point, the beginning, something like that. The item in the situation that will not change. No matter what happens, that will always be the same. The slope, aka the constant rate of change, is the item that can change in a situation. This is usually described using words such as per, each, monthly, daily, yearly. Now, that's not exclusive. Sometimes you will see per next to both of them, but this is not that problem. When we get there, we'll talk about that, all right? But if we look here, I want you guys to think about this rationally. You go to the bowling alley. You rented shoes for $5. Each game costs $8. Which one of those things will you only pay once, the 8 or the 5?
5.
The 5. You will have to pay that $5 shoe rental fee no matter what. You have to pay $5 for those stinky shoes. Now, if you just bowl one game, then it's just 8 plus 5. But if you bowl 2 games, it's 8 times 2 plus 5. If you bowl 3 games, it's 8 times 3 plus 5. So which one of those numbers changes, the 8 or the 5? The 8. The 8 can change depending on how many games you bowl. So, for the bowling situation, the y-intercept is 5, and the slope is 8. That $5 fee ain't gonna change, boo-boo. It doesn't matter if you bowl 100 games. It's just $5 for shoes.
Can I write the equation?
It's too much. And then the equation, Adrian, what's my equation?
Y equals 5x plus 8.
Okay, let me ask you a question. We're writing a linear equation in this form. Y equals mx plus b. M represents the slope. B represents the y-intercept. Looking at this, we said the y-intercept was 5. The slope was 8. So what should my equation be?
Y equals 5.
Okay, hold on. What is 5 here? Is 5 the y-intercept or the slope? Look here. What is 5?
So
No, what is 5? The y-intercept is,
is
what is it? The y-intercept is 5. So, is 5 going to be the b or the m? Okay, what is m? M is the what? The slope. Everyone else, just m. M is the slope. B is the y-intercept. So, is 5 going to be the y-intercept or the slope? What does it say right here?
5.
Is 5. So, I'm going to ask you again, is 5 the m or the b? 5 is the b, which means 8 has to be the m. So, what's your equation?
Y equals 8x plus 5.
Perfect. Y equals 8x plus 5. Don't always assume that slope is the first number you see. It could be the second. It could be anything. You just have to read the question carefully. All right, let's try a couple more here. We got 3 problems. Azanza, you're making for whatever reason, your hobby is to make bead necklaces.
always do
The
that.
necklaces always contain 20 spacers and then 4 beads per inch of necklace length. So, you got two numbers. Which one of those do you think is going to be your slope and why?
My slope.
So let's read it again. Read it for me. Actually, here, read it for me, starting with the word "the."
The necklaces always contains 20 spacers and 4 beads per inch of necklace length.
Okay, so one of these numbers, the description, tells you it's never going to change. One of them could change, depending on the necklace. Which one of these numbers is never going to change?
The 20.
The 20, the spacers. Since it's never going to change, is that going to be your slope or your y-intercept?
The one.
The y-intercept, because it's never going to change. You're always going to use 20 spacers for some reason. Even if you make a 1-inch necklace, 20 spacers.
Really?
Really? Why? Because math is crazy. That means your slope has to be 4. Here's a key word. 4 beads per inch. That means every inch. How many beads are you going to use?
4.
4. So 4 times 1, 4 times 2, 4 times 3, 4 times 4, so on and so forth. What is my equation, Azanza?
Y equals 4x plus 20.
Perfect. Okay. Good. You want to do the next one? Okay. So, a hummingbird beats its wings at a rate of 150 beats per minute. What is my slope? Roman Omo.
The slope is 150,
And what's your y-intercept?
60.
Let me ask you a question. We're talking about a hummingbird, 150 beats per minute. Before it starts flapping its wings, how many beats per minute? When it's on the ground, before it's taken off?
0.
0. So my y-intercept there is 0. You have to think of this real world scenario. Let's say in the sky, 150 beats per minute. Let's say he was sitting on a branch. Is he beating his wings? No, so it would start at 0. So my y-intercept is 0, which means the equation is going to be what?
Y equals 150x.
Y equals 150x. Colton! The last one, dude. Billy! Hi, Billy. Billy goes to Crystal Lake Campground. He pays $32 for each night, plus a one-time trash disposal fee of $11, hombre. What's your slope? What's your y-intercept? What's your equation? Tell me now.
The slope is 11, the y-intercept is 32, and the equation is y equals 11x plus 32.
Okay, let's pause. Let's read it for me. Read me the scenario.
Billy goes to Crystal Lake Campground and pays $32 for each night, plus a one-time trash disposal fee of $11.
Okay, so remember that the slope can change. The y-intercept cannot. So reading that scenario, which one of those things is always going to be the same?
Did I mix it up?
Yes.
Oh,
So which one of those is always going to be the same?
11.
The 11. It's a one-time. Keywords, one time. If you pay something one time, do you pay more than once?
No.
No, that's why it's called a one-time fee. So, the y-intercept's 11. This can change because you're paying $32. What's my key word? Each. $32 for each night. So that can change. One night 32, 2 nights 64, 3 nights 96, so on and so forth. Which means that your equation, Ms. Davis, is what?
Y equals 32x plus 11.
Y equals 32x plus 11. Yes! 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 Hercules! Hercules! Questions?
What?
You never saw the clips? With Eddie Murphy?
I heard this on
No? Ways you know you're old. No, it came out like, well, when you were like 4. Questions? Questions? Questiones!
No, sir.
Right, then this old timer right here is going to change the slide.
You need help?
Okay, 4, 3, 2, 1.
Isn't Crystal Lake?
Now we want to go in and we want to write the equation from the scenario, and then we're going to evaluate it. So, first thing, we have to look at the scenario, we have to write the equation, and then we have to evaluate it for a specific item. So the cost of renting a sailboat is $22.50 per hour per. Keyword, that could mean something, we'll come back to it. Plus $9 for life jackets. Assume that it's just you. $9 for life jackets. $9. Don't let the S throw you off. Write an equation in slope-intercept form to calculate the total you would pay for using the sailboat for 4 hours. So first of all, we have to identify the one-time thing, the thing you're only going to pay once. What's the only thing you're going to pay once for?
Life jacket.
What? Light jackets, right? Light jackets. So, what number represents light jackets? $9. So it's $9. You're only going to pay that once. And it doesn't really matter if you have one light jacket or four. We assume, when all else fails, it's just you in this scenario. Assume you have no friends. Assume it's just you out on the sailboat all by yourself.
Let's be realistic.
What?
Assume.
Well, yeah. I mean, let's say this is me. I'm out there on my lonely sailboat all by myself. I'm sailing away. All right. Then what's my slope? 22.5. So I have my slope. I have my y-intercept. I don't know why I didn't just make that appear. And then I can write an equation. Jason, what's my equation?
Y equals 22.5.
Perfect. So y equals 22.5x plus 9. The last thing is, though, you must evaluate it using the sailboat for 4 hours. So let me tell you, this is where you have to be careful. As I said, at some point I was going to switch it up. It's not yet, but be careful. We want to know for 4 hours. So
Nice.
stay there. Hours. $22.50 per hour. $9 per life jackets. I'm not switching it up yet here. I'm still not. $22.50 per hour, okay. 4 hours, that's going to be X. Substituted out, we get 4. But that won't always be the case. But this one, it is. So we take out the X. We do y equals 22.5 times 4 plus 9. You multiply, and then you add. Y equals, what's 22.50 times 90 plus 9. So for 4 hours, Y, 4 hours Y, you get $99. That's the total cost. Question?
That's just for yourself.
What happened?
That's just for yourself.
That's just for me. I'm sailing away all by myself. Let's just draw me on my sailboat right here.
You gotta dress into your.
Who are you waving to, though?
And then it gets worse. There's like a little bird here and it poops up. It happens. All right, last one. The one most people get wrong. Let's put these away for a second. And I want Mr. Jackson, Dante. Read the scenario.
I saw it coming. Alright. A balloon is currently at an altitude of 16,000 feet when it pops. The balloon begins to fall at a rate of 32 feet per second. Write an equation to model the situation.
Okay, I want everyone to pause. I want everyone to think about this situation. I want you guys to think, don't say it. I want you guys to think about what the slope could be. I want you guys to think about what the y-intercept could be, and I want you guys to think about the equation. I do. Most people get this wrong. So, it's not a trick question.
I know.
It's a real world question.
Balloon is spelled
Where?
Oh, it is the second balloon. And, well, hey, it happens. So, let's give Dante, since he read it for us, let's give him the first crack. Dante,
Yes, sir.
I'll give you 2 guesses. What's my slope?
You're slow. 32?
Wrong. What's my slope?
Dang.
What's my slope?
16,000.
Wrong.
What is that?
Wait, hold on. Some people, it just clicked. For the rest of you, it's about to happen right here.
Yo.
The balloon's at an altitude of 16,000 feet when it pops. So this is the balloon.
Alright.
Picture the balloon. It pops. What happens to it?
That's a really long balloon.
What should my slope be? Positive 32 or negative 32? Because when it falls, you have to read the thing. Think about it real world. If your balloon pops and it goes up, you're in a dream world. That's not normal. Maybe you're in outer space. However, here on Earth, when the balloon pops, little pieces of balloon, they don't go up, they go down. At some point, maybe a strong wind pushes them up a little bit. But no, they go down. They fall down. This balloon pops and it goes down to the ground. Okay? And even if you didn't get that, the graph was right here kind of telling you the slope of the line should have been. Nobody looks at the graph?
No.
Oh, you see? Visual clues! Falls! Graph's going down! Ah! Slope is negative 32. Y-intercept, yes, it starts at 16,000. My equation is y equals negative 32x plus 16,000. Don't worry. Because everyone gets this wrong. Every year, every class, they miss the same thing. Falls at a rate of 32 feet per second. Just like the question on your exam or the practice test. When the tub drains, what does drains mean? Positive or negative? Negative. You have to read the whole question. Guaranteed you're going to see something like this at some point, somewhere. You have to look for those key words. What is math? This isn't even math. This is reading. Reading.
I don't like reading.
See, I'm so good at reading.
Okay, so now that we have our equation, follow-up question, how long will it take for the balloon to reach the ground? Be careful. How long will it take for the balloon to reach the ground? The altitude is represented by y. Since we want to know when the balloon will hit the ground, we will set y to 0 and solve. What do you mean set y to 0 and solve? I want to know when this balloon hits the ground. What's altitude? The x or the y?
That's the one.
That's the Y.
What's altitude?
Y.
The y. So we want to know how long it takes for y to get to 0. So usually we write y equals something here.
Plus, what's gonna be on the floor?
0 is equal to negative 32x plus 16,000. I told you at some point we'd be solving for y. This is one of those scenarios. You always look at your graph. Wait, what are they asking about? Oh, when it gets to 0. Okay, that's altitude, not time. So, I go ahead and I solve. To solve this, 2 steps. What's the first step?
Add,
No,
add
you
32.
add this time because it's a negative, so you add 32.
I want to keep this here.
Oh.
I want to get rid of this. How do I get rid of this? No, this is addition. What's the opposite of addition? So I subtract 16,000 from both sides. This really is not complicated. It's just 2 steps. So I have negative 16,000, and all of you have calculators, is equal to negative 32x. What should you do now? Divide both sides by what? Negative 32. You're trying to get x alone. So you divide both sides by negative 32. Somebody do that for me and tell me what x is equal to. X is equal to what? 500 seconds. So the answer to this question, 500 seconds. You have to write an equation. This is the one time that we've seen all day where you were solving for y, and then your answer, x, the time, is 500 seconds.
And that's a wrap.
And that's a wrap. Questions on this one?
Wait, this is amazing.
There were a whole bunch of crazy stuff at you, right? You had to determine that the slope was negative there, because not at that point everything else you do was wrong. And then you had to realize that you were solving for y. How do I know I'm solving for y? How long will it take for me to get to the ground? Well, that's a question that involves x. Since I'm solving for that, I'm going to substitute in for y. Any questions? This is a tough one on here. This is the toughest one of the whole lesson. Will you see something like this in your homework? Maybe 1. No classwork, not your homework. Classwork, 1. Questions, yes or no? Yes.
On your test, we'll see it for sure, though.
You'll see something like this. You'll probably have to one where you solve for x, one where you solve for y. How you can determine? You simply read the question. They'll tell you what you're solving for, but you have to read it. Don't just plug in numbers randomly. Yes, what's up?
So for y, you have to divide?
Well, because the thing is, the only reason you're dividing is that's not Sunday.